So we've talked a lot about exponents and about exponential functions. The next part to talk about is what is the inverse of an exponential function. So we know what the inverse of a function is, kind of what undoes it. So that's what logarithms are. So the first thing we're going to do is what is a logarithm, and then go over properties of logarithms. So again, the first thing we're going to talk about is what is a logarithm. So a logarithm, is always written log. It's going to have a base. Base here, let's say, is b. And it's kind of like sine or cosine. It's not just, you don't just write log base b. You have to say of something. So let's say an a here. And let's say it's equal to some number. What does this actually mean? So when I say log base b of a equals c, what this actually means is that b raised to the power of c equals a. So you kind of read it circular. This would be b to the c equals a. So that's what a logarithm is. For example, log base 2 of 8. What is that? Well, this is saying 2 to what power is equal to 8? Well, 2 cubed is 8, so log base 2 of 8 is equal to 3. What about log base 3 of 27? So this is saying 3 to what power is equal to 27? Well, 3 cubed is 27, so I would put a 3 there. What about log base 2 of 1/2? So this is saying 2 to what power is equal to 1/2? Well, 2 to the negative 1 is equal to 1/2. Remember, a negative exponent means to move it to the denominator and make the exponent positive. And then lastly, what about log base 2 of 1/8? So 2 to what power is equal to 1/8? Negative 3. Because 2 to the negative 3, that would be 1 over 2 cubed, which is 1/8. So that's what a logarithm is. A logarithm is the inverse of an exponential. So you say here's an exponential, logarithm is kind of going in the opposite direction. Different properties that we're going to go through. We're going to go through 6 of them. For this, we're going to go back to our properties of exponents. So the first property of exponents that we did was b to the 0 equals 1. That was our first property. From that, in terms of logarithms, what we get is that log base b of 0, of 1 is 0. So this says b to the 0 is equal to 1. So from the first one, that b to the 0 is 1 from your exponential properties, I get that log base 1 is 0. This is true for any base. Secondly, our second property of exponents was b to the x times b to the y is b to the x plus y. What does that tell us in terms of logarithms? This says that log base b of x plus log base b of y is equal to log base b of x times y. So if you have two logarithms where they have the same base, you can combine them by multiplying on the inside. So for example, could I simplify log base 2 of x plus log base 2 of w? Well, these have the same base, so yes, I can simplify these to be log base 2 of x times w. My third property, if you remember from exponentials, was b to the x over b to the y was b to the x minus y. What we get for logarithms now is that log base b of x minus log base b of y is log base b of x over y. So if I have the same base and I'm multiplying, I can take the insides and divide them. So for example, can we write this as a number? How about log base 2 of 8 minus log base 2 of 4? Well, they have the same base, so I can combine them. And of course, you could just write these as numbers, but I want you to see how you can combine these. This will be log base 2 of 8 divided by 4, which is log base 2 of 2, So this says, what power do I raise 2 to get 2? So that would be 1. So if you're subtracting on the outside, you can divide on the inside. My fourth property, my fourth property is coming from the fact that b to the negative x is 1 over b to the x. So if you remember that from exponents, what this tells us in terms of logarithms is that log base b of 1 over x is negative log base b of x. So from the exponential, when we get that you move this into the denominator, this is kind of like using the quotient. I can just move the negative out front and rewrite my x. So, for example, log base 2 of 1/2. Here my x is 2, so this is negative log base 2 of 2. Well, I know log base 2 of 2, that's 1. We did that before, so this is negative 1. My fifth property, if you remember my fifth property, that was b to the x to the y, was b to the xy. What I get from this one is log base b of x to the n. I can bring out this exponent out front, so this is n log base b of x. So continuing with our log base 2 examples, let's do log base 2 of 2 to the 5th. I can bring out this exponent to be a coefficient in the front, so this is 5 times log base 2 of 2. Log base 2 of 2 is 1, so this is 5 times 1, which is 5. So anytime you have an exponent, you can bring that out front as a coefficient. Property 6. We're actually not going to do one with the original property that we had for exponents, so there's not really a corresponding one there. But the last property that we're going to do, and we've used this quite a few times, but for any base, log base b of b is just 1. So all this says is that b to the first power is b. So those are the 6 properties of logarithms that we're going to use. One useful thing to know, though, is how do I plug this into my calculator? If I want to get a decimal approximation, how do I do that? And that comes from the change of base formula. So the question is, what is maybe log base 3 of 10? If I want a decimal approximation of this, what is it? So 3 to what power equals 10? Well, it's going to be 2 point something because 3 squared is 9, which is almost 10. But what actually is it? So the change of base formula says the following. Log base b of x. What you can do is choose your favorite base. Now there are 2 standard bases that we're going to learn. The 2 standard bases is log base 10 and log base e. So remember, we were doing a lot of work with e in the exponentials. Log base 10, that's just a log on your calculator. So on your calculator you have a log button that's understood to be log base 10. Log base e, that's the natural log, written as ln, and you also have a button for this on your calculator. These are your 2 standard bases, which is why you have those buttons on your calculator. So go back to our change of base. We're doing log base b of x. What you're going to do is pick your favorite base. Now, if I were you, I would probably pick 10 or e, but it's up to you. Pick your favorite base. Let's call it a. The way you do this is log base a of whatever's in parentheses, so x, divided by log base a of your old base. Now, why is this helpful for us? In your calculator, you're going to type in log of x divided by log of b. You could choose 10 as your base, and that's what you would get. Or you can choose natural log. So this would be natural log of x divided by natural log of b. So the change of base formula, what it says is pick your favorite base. If you're going to be smart about it, you're either going to pick 10 or e. And then divide log of the inside, log of the old base. Or natural log of the inside divided by natural log of the old base. So go back to what we were trying to figure out. We were trying to figure out log base 3 of 10. I want to know, give me a decimal approximation for that. So in your calculator, you're either going to use log or natural log, doesn't matter. This would be log of 10 divided by log of 3. Or if you want to use natural log, that's fine. Natural log of 10 divided by natural log of 3. And what do we get? If you type this in, you'll get approximately 2.096. You get the same answer either way. So if you want a decimal approximation, convert it to a different base. Use either 10 or e, and just do log of the inside, log of the natural old base, or natural log of the inside divided by the natural log of the old base, and you'll get a decimal approximation. So those are your properties of logarithms, and that's how you find a decimal approximation using logs.